Welcome back, guys. In this episode, let's talk about CES, or constant elasticity of substitution production function, and let's find out technical rate of substitution, elasticity of substitution, and elasticity of scale for this constant elasticity of substitution production function. If we have a general constant elasticity of production function, or CES production function, y is equal to AL to the power of rho plus BK to the power of rho, all to the power of 1 over rho. So find out the technical rate of substitution, elasticity of substitution, and elasticity of scale. In order to make it simpler, so let's assume that A is equal to B and equal to 1. So then this function will equal to y equal to L to the power of rho plus k to the power of rho, all to the power of 1 over rho. So first of all, let's find out the technical rate of substitution for this CES production function. We know that from the previous videos, one of the previous videos that we drive the technical rate of substitution. Technical rate of substitution is equal to the marginal product of labor divided by the marginal product of capital, which means technical rate of substitution of L for K. Marginal product of labor divided by marginal product of capital. So what is the marginal product of labor? The marginal product of labor then equal to the partial derivative of y with respect to L. This one is equal to the partial derivative of y with respect to k. So based on this formula, we will find out the technical rate of substitution. So then the technical rate of substitution is equal to the partial derivative of y with respect to L. Then let's find out the partial derivative of this one. So it's equal to 1 over rho multiplied. We have to find out first the derivative of the whole terms, which is 1 over rho multiplied by L to the power of rho plus k to the power of rho, all to the power of 1 over rho minus 1, multiplied by, now we need to find out the derivative of the inside of this function, which is L to the power of rho in this case, because we are finding the partial derivative of respect to L. So this term will become equal to 0. So then this one will become to rho multiplied by L to the power of rho minus 1, divided by, now the partial derivative of y with respect to k. At first we have to find out the partial derivative of the whole terms. Then again is equal to 1 over rho multiplied by L to the power of rho, k to the power of rho, whole to the power of 1 over rho minus 1, multiplied by rho, in this case k, because we are finding the, we need to a positive sign here, rho multiplied by k to the power of rho minus 1. Rho minus 1, because we now need to find out the partial derivative of this function, inside function, with respect to k. So here, this rho will be cancelled out with this rho will be cancelled out with this rho, and this whole term will be cancelled out with this whole term. So we'll have technical rate of substitution for this elasticity of substitution production function, L to the power of rho minus 1 divided by k to the power of rho minus 1. So we'll have L over k whole to the power of 1 minus, L divided by k whole to the power of rho minus 1. So we can write down k divided by L to the power of 1 minus rho. So in this case, the technical rate of substitution for this CS production function is equal to either this term or this term. Anyone you are comfortable with that. So this is the technical rate of substitution. Now let's move to the elasticity of substitution. Well, we know that we have this formula for the elasticity of substitution, this one, which is elasticity of substitution is equal to the derivative of logarithmic form of the input ratio, which is K divided by L, with respect to the logarithmic form of TRS, the absolute value. So in this case, because we didn't consider the negative term in the technical rate of substitution from the beginning, we work with the absolute value. So it doesn't, we don't need to add the absolute value sign here. So now we will have this term here. So we need to find, we need to make this formula appropriate for this one to find out the elasticity of substitution. We will have TRS is equal to K divided by L all to the power of 1 minus rho. 1 minus rho. So let's raise up both sides to the power of 1 minus 1 over rho. So then, let me clean this side. So then, when we raise up both sides with this power, we will have the technical rate of substitution to the power of 1 divided by 1 minus rho, and this side is equal to K to the power of L. So now is the time to take the natural log of both terms. We will have ln of K over L is equal to, so now we will have 1 minus rho, because it will change this side, sorry. So we will have 1 divided by 1 minus rho multiplied by log of TRS. So now, based on this formula, when we take the derivative of this one, natural log of input ratios with respect to this term, then we will have the elasticity of substitution. So then, let's take the derivative of log of K over L with respect to natural log of TRS. Then we will have, when we take the derivative of this term, then we will have 1 divided by 1 minus rho. So by this formula, or by this solution, we now come to know that the elasticity of substitution for a constant elasticity of substitution production function is equal to a constant number, and it depends on the value of rho. It's not variable, it's not changing, it's not depends on the value of K or L or anything else. It's dependent on the value of rho, and rho is a constant number, it's a fixed number. So then the elasticity of substitution for a CES production function is constant. So now let's move to the next stage and find out the elasticity of scale. The elasticity of scale. The elasticity of scale for this CES production function. So now again, why, if we like a plus b is equal to 1, is equal to a is equal to b equal to 1, if we consider this condition, we'll have L to the power of rho plus K to the power of rho all to the power of 1 over rho. And if we scale up, then y t is equal to like TL to the power of rho plus TK to the power of rho all to the power of 1 over rho. Then we will have YT is equal to T to the power of rho L to the power of rho plus T to the power of rho K to the power of rho all to the power of 1 over rho. Then Y of T after scaling, so we will have like a common value here, T to the power of rho, T to the power of rho. We will have T to the power of rho, then L to the power of rho plus K to the power of rho and whole to the power of 1 over rho. So we can take out this one out of this parentheses, then we can write down Y of T is equal to T to the power of rho and again to the power of 1 over rho, because when we take out this one, so this power is also for this. So then multiplied by L to the power of rho plus K to the power of rho all to the power of 1 over rho. So this one. So now this one will cancel out with this one. Then we will have YT is equal to T multiplied by L to the power of rho plus K to the power of rho all to the power of 1 over rho. So now, in order to find out the EX, we had this formula. EX is equal to the derivative of YT with respect to T multiplied by T over f of Tx, or again YT. So f of Tx or Yt. So we evaluate this one at t equal to 1. So now, if you take the derivative of this term with respect to t, so the power of this t is equal to 1. So what we'll have, we will have Ex is equal to L to the power of rho plus K to the power of rho all to the power of 1 over rho. Then multiplied by T divided by f of Tx. F of Tx is equal to this one. This is f of Tx. Then we'll have T divided by L to the power of rho plus K to the power of rho all to the power of 1 over rho. So either you evaluate this one at t equal to 1 or cancel this one with this one and also this one with this one, then elasticity of scale for the case of CES production function is equal to 1. For the case of CES production function is equal to 1. It means the CES production function is constant return to scale. It's constant return to scale. So overall, the conclusion is the elasticity of scale for the CES production function is equal to 1. It means the property of constant return to scale is well defined in the concept of CES production function. Again, thank you so much guys for watching this video. If you have any specific comment, any specific question, any specific concern about microeconomics, you can write down below in the comment section. I will try to answer you as soon as possible, or I will try to make a specific video for your specific question. So, and also I request you to subscribe my YouTube channel in order to watch the next videos as well when I upload a new video related to microeconomics or labor economics in this video channel, or any other topics related to any subject of economics, then you can watch by uploading that video right away. So subscribe and also turn on the notification. Thank you so much. See you next time.